Hello, I hope you're all having a good day. Today's lesson for week 13 of NTI, we will be stepping away from looking at the periodic table and atoms and elements, and instead be looking at wavelength and frequency. Now there is a calculation that we have to do with this lesson, and that's one reason why we're making this video. But we're going to go through this lesson and hopefully gain an understanding of it. Alright, so let's start off. Let's talk about wavelength. Alright, wavelength is the distance between corresponding points on adjacent waves. Alright, looking at the picture, it would be from the crest to crest, this distance in between them, or the trough in this one is cut off, but it would be right there. Alright, this is wavelength. Wavelength is measured in meters. Alright, so Ilm. Alright, sometimes they talk about nanometers, but we're not going to be looking at that today. We're just going to be looking at meters. Now, there is a symbol that stands for wavelength, and it's this Greek symbol called lambda. Alright, so lambda is wavelength. Okay, we're going to be talking about frequency. Frequency is the number of waves that pass a given point in a specific time. So, like, say you were sneezing a lot, and you sneezed 10 times in 1 minute. Okay, that is the frequency that which you sneeze. Well, in this case, how many times does a full-length wave happen in a given time? Seconds is usually what we use for that. Okay, now the symbol for frequency is this Greek symbol called nu, and it looks like a V with a little hat on one of the ends. That's nu. Now we measure frequency in something called Hertz. All right, that's the unit. Just like meters is measuring the wavelength, Hertz is measuring the frequency. And it is the number of waves that pass a given point in a specific time. So let's say this time frame right here happens to be 1 second. And I just misspelled second. That's horrible. Alright. As you can see, if it has high frequency, which this first picture does, high frequency, a lot of waves pass through it. The wavelengths are very small. So that means a small wavelength. Because a lot of them go through at that given time. A low frequency usually means large wavelength. So that means that when one of them goes up, frequency, which is that symbol, the other one must go down. When frequency goes up, wavelength is smaller. When frequency goes down, that means the wavelength is getting larger. That is the relationship between the two. Now, they discovered an equation that uses the speed of light. And this equation allows us to calculate what the wavelength is, or the frequency is, of these waves. Okay, so we're going to use these two equations to calculate and practice those calculations, and your homework is going to be some calculations over it. All right, so the first one, wavelength, which remember is lambda, is 3 times 10 to the 8th divided by the frequency. If you were going to use a calculator, all right, how would you set this up? Well, you would definitely need parentheses around the 3 times 10 to the 8th. And then you would put the little divide sign, and then whatever the frequency is in hertz. Okay, now the good thing is we already have learned scientific notation. And if you notice, some of these are in scientific notation. So hopefully you remember a little bit about that. Okay, for frequency, which is nu, you're going to type in parentheses 3 times 10 to the 8th, in parentheses, the divide sign, and then the wavelength that will be in meters. Right, and we're going to try to use numbers that are fairly easy for you to type in, especially if you're trying to use your calculator on your phone. It might be difficult. You just got to get used to calculating these. And don't worry, in the examples that we do, if you do them on your calculator, you should get the same answer as me. And if you don't get the same answer as me, then you need to figure out, like, okay, Ruggles or Miss Bryan, how do I type this in so it shows up the right answer? Now this equation, when we look over it, looks like this. Nu is c over lambda, because this is nu, and that's c over lambda. So if you ask a physicist, hey, what's nu, man? He's going to say c over lambda. And that's a really corny joke, but that's how I remember this equation. So we're going to go ahead and practice a couple of the wavelength equation. Is this top one right here. All right, so it's going to be 3 times 10 to the 8th divided by frequency. Okay, so let's go back. I'm going to use this equation right here. All right, frequency is 3 times 10 to the 8th divided by the wavelength. This equation, speed of light divided by the wavelength. Equations. All right, speed of light is always on top. The top number is always 3 times 10 to the 8th. And then you just divide it by the frequency or the wavelength, depending on what you look for. All right, if you have any questions, make sure that you contact one of us and ask about it. Thank you. All right, our first one. Okay, the first step is we need to figure out what is it asking for. It says, what is the wavelength? All right, so we're going to use the wavelength equation. Go ahead and write that out. Wavelength is going to be 3.0 times 10 to the 8th. And this is in meters per second, by the way. Divided by whatever the frequency is. And we have the frequency right there. So we type in parentheses in our calculator 5.2 times 10 to the negative second. All right, and this is Hertz. So if I type this into a calculator, what I get is 57652395576, which is really horrible if you have a calculator on your phone. If you're using a scientific calculator, it gave it to you in scientific notation, which is what I'd rather see. Right? This is what you probably got if you typed it in on a scientific calculator. 5.77 times 10 to the 9th. And what is my unit for this? Meters. All right, because we're measuring everything for wavelength in meters. All right. This is actually 577 nanometers, but we're not looking at nanometers. We're just looking at meters. So this is my answer. Okay, let's try. So that's what we're going to use. These two, the other calculation. All right, the wavelength of light is 405 meters. 405 meters. All right, it says calculate its frequency. So I'm looking for frequency. Frequency is 3.0 times 10 to the 8th meters per second. Divided by 405 meters. Note, this one's a little bit easier to put into a calculator. And you're going to get this answer. But if you get it in scientific notation, which is easier, it's 7.74 times 10 to the 6th. And what is my frequency in Hertz? So here is my answer. Okay, so once again, it's just figuring out what number goes on the bottom. Now, I would like to make note, the top number is always going to be 3.0 times 10 to the 8th. That's always the top number. It's never the bottom number. All right, so you always put that one on the top. It's one. All right, let's work out one more. It says calculate the frequency of 250 meters. So this is my wavelength. All right, my wavelength. So I'm looking for frequency. So once again, so frequency is equal to 3.0 times 10 to the 8th meters per second. It's always on the top. Divided by the wavelength that they give me, 250 meters. I get 1, 2, followed by 5 zeros, and this into scientific notation is 1.2 times 10 to the 6th, and this is in Hertz. All right, so as you're doing these problems, you're either going to get your answer in, a full-blown number or in scientific notation. We would rather have your answer in scientific notation. So if you could put your answer into scientific notation, we're going to be so much happier about it. All right, but this is our calculation.